Today we're looking at two things. Like I said, most of it's pretty easy. We are going to perform operations with functions, and we're going to find compositions of functions. So pretty straightforward, pretty easy. So hopefully we can move through pretty quick and you have a little bit of time to get to work. So on number one, I have two different functions. I have the function f of x and I have the function g of x, and it wants me to perform these four operations at the top up here. It wants me to find that, this, and that. So, if I'm going to find f plus g of x, what do you think I need to do?
X squared plus 4 plus x squared.
There you go. As Kaylee said, if I want f plus g of x, all I need is x squared plus 4 plus the square root of x, and that's what I'm looking for.
Times x.
What?
No. Oh, of x, sorry, my brain's going.
So that's the first one. The second one is f minus g, which is very similar to the first one. What's the only change?
Yes.
I'm going to have a subtraction. Okay, then we get to f times g of x. And on that one, we're obviously multiplying. Make sure you put parentheses around the x squared plus 4. And then the last one is division, which gives me x squared plus 4 over the square root of x. So those are function operations, adding functions together, subtracting them, multiplying functions, and dividing functions. Those are your function operations that we're talking about in our learning goal. Okay, now it says state the domain of each new function. I don't want to go through and state the domain of each new function, but I do want to go in and state the domain of the last one, the f divided by g of x. So it's a good refresher on how to find domain. What am I looking for when I want to find domain? Radical and denominator. And when I have both, like in this case, which one do I pay attention to? And how do I handle a radical? Set the inside equal to 0. We usually have to solve, but this one's good to go. Then what do I need to do? Number line. Okay, so what's the number on the right going to give me? Positive, and the number on the left is a negative. So from that, we can see that our domain is what? Now remember, if I have a radical, how do I want the domain given? Interval notation. Very good, Colleen. If I have a radical, I want the domain given in interval notation. So what's my interval notation?
0 to infinity.
0 to infinity. Parenthesis or bracket on the 0?
Parentheses.
Why?
Because it's in the denominator.
Alright, that's the answer I'm looking for, because the radical's in the denominator. That's what I want to hear. Okay? So, you're adding, subtracting, multiplying, dividing your functions, and then you're giving me the domain of the division. Alright, let's do one more. Let's do number 9. So let's work number 9. Oops. All right, number 9. My two functions are f of x equals 1 over the square root of x, and g of x equals 4 radical x. So I want to add, subtract, multiply, and divide. So adding is pretty straightforward. 1 over the square root of x plus 4 square root of x. Subtraction is also straightforward. Now multiplication I can do a little bit more. What happens when I multiply there? The square roots. The square roots cancel, and I just end up with 4. Then I have division. So I take 1 over the square root of x over 4 square root of x. So we need to talk about how to handle that. Anybody know what to do in that situation? Alright, here's one way to do it, like Natasha's talking about. Instead of writing it like this, let's take the top one divided by the second one. So I take the first one divided by the second one. And what does that division tell me to do? Say it again. It tells me to change this to multiplication and change that to a fraction. So 1 over the square root of x times 1 over 4 square root of x. So it changes to that. And then what do I get when I multiply there? Square roots cancel out, and I end up with 1 over 4x. That's probably the easiest way to do it right now. Eventually, I'm going to show you a different way, but when we're doing something small like this, that's the quickest and most efficient way, is to write them side by side, flip the right one, and multiply. Okay, so when you're dividing fractions like that, write them side by side, flip the right one, and then multiply them together. That's what I want you to do right now. Okay, we'll eventually get to some other things in this class, and I'll show you a different method. But when we're doing functions that look like this is the easiest way to do it. So here is f divided by g of x. That's the one I want the domain of. So what am I concerned about on that one? 0 in the denominator, so what makes it 0? 0 does, and since there's no radical, my domain must, how do I start? How do I state my domain? All real numbers except, so this would be all real numbers except. And make sure you put that x equals in there for me. Make sure you put that x equals 0. All real numbers except x equals 0. Alright, so that is performing operations with functions. Now we want to look at compositions of functions. So move down to, the one I want to look at is 19. 19 will work. Okay, on 19, my two functions are f of x equals 3 minus x squared, and g of x equals x cubed plus 1. And if you notice in the directions, it wants me to find 3 things. How do you read that on what it wants? It's not f times g. F of g. Okay, so it says f of g of x, g of f of x, and f of g of 6. So it wants me to find those 3 things. Now, I like to write it a different way than they have it written. So understand that the way I write it is meaning the same thing as the way they write it. So instead of f of g, I like f g of x like that. I like g f of x, and then I want f g of 6. So those 3 things mean exactly the same thing that are in your directions in your book. Okay? So, if I'm going to find f of g of x, what is it they want me to do? Very good. Alright. So Zakiah says that f of g of x is 3 minus x cubed plus 1 squared. That is correct. Okay? So if I want f of g of x, I'm going to take g and I'm going to plug it in to f. Okay? So I take g and put it everywhere I see an x. Okay, g of f of x is going to be the reverse. This time I'm going to take f and put it in for g, so I'm going to take f and put it in for g. So 3 minus x squared, that's going to be cubed, and plus 1. Any issues there? Okay, and then f of g of 6, what do we want there?
just substitute 6 for like the first one.
Very good. Okay, f of g of 6 is the same thing as this one right here, except we're putting 6 in wherever we see an x. So I take what I wrote down and put a 6 in that spot. So I have 3 minus 6 cubed plus 1 squared. Yeah. We do want to solve that if you're dealing with a number. If you're dealing with a number, go ahead and work it out. So does anybody know what 6 cubed is?
216.
216, and 216 plus 1 gives me 217. And we worked this out last hour. So this gives me negative 47,086 is what we end up with if you square that and put it with the 3. So that's finding compositions of functions. We found f of g, g of f, and then we found f of g of 6. Okay? Let's look at another one. Move over to, which one did I want to look at? Go to 25. Let's look at 25. Okay, on 25, what are the directions on 25? We just want to find f of g on 25. Okay, so what do I need to do to find f of g? Plug in g into f. So what does that look like, Lauren?
5 over the square of 6 minus x.
5 over the square root of 6 minus x. Very good. And just for practice, I want to go ahead and find the domain of this composition. So what do I need to do? Set the inside equal to 0. So I get x equals 6. Number line. Okay. Plug in 0, that'd be the easiest. What happens when I plug in 0? Positive, which means my other side is negative. So what's my domain going to be? Negative infinity to 6. Bracket or parenthesis on the 6? Parenthesis because it's in the denominator. Very good. Excellent. Okay? Now we're going to kind of do the reverse of compositions of functions. We were taking 2 different functions and putting one inside of another. Now we're going to take a function and kind of take it apart and find two functions that were put together to make that function. So I want to look at 31 looks good to start with. Okay, so again, they're giving me a composition, so they're already telling me that 2 functions were put together to get the function that's up there. Okay, so I have h of x equals 6 over x plus 5 minus 8. So my job is to figure out what f is and what g is. Okay, now I always want g to be the function that was put inside of f to end up with what I got. So g is the inside. F is the outside. So any thoughts on what g might be on 31?
X plus 5.
X plus 5. So if g is x plus 5, what does that mean f is?
6 over x minus x.
6 over x minus 8. And this one, this type of problem, you can always check to see if you got it right. What can I do to see if I got it right? Plug it back in, because if I plug g into f, I should end up with what I got if I did it correct. So if I take x plus 5 and put it into f, do I end up with that?
Yes.
Yes. Now, on these type of problems, there's always multiple correct answers. Does anybody see anything else I can do besides the f and g that I already have?
G could be 6 over x plus 5, and f could be x minus 8.
Hey, what do you guys think about that? Does that work? Yes, that works. Very good, Kathleen. Chris, did you see another one?
Well, I'm thinking something that was similar to Kathleen would be 6 over x plus 5. And could you do 1 over x minus 8? Or would that not be correct?
No, that wouldn't work. So I don't think if you combine it, that you end up with the same thing. All right, let's try another one. Let's look at 37. So 37. I want to get an f of x and a g of x. So Blake, what do you think on a g of x? What you got, Bobby?
I said it'll be U of X equals X minus 5.
X minus 5. So what does that mean f of x is?
8 over X squared.
8 over x squared. What do you guys think?
Yep.
That works. Very good. Let's get another one. Sakai, did you have another one? No? Okay, Rachel, you see another one? What you got?
G of x be x minus 5 parentheses squared or 8 of x.
Does that work?
Yep.
Yes, that works as well. Does anybody see anything else? Okay, here's a rule of thumb on what you want whenever you're looking for a g. G is always in parentheses, in the denominator, in a square root, or in an absolute value. That's the easiest way to find g. You can always choose a g that's inside parentheses, in a denominator, in a square root, or in an absolute value. It's always pretty easy to pick the g that's in one of those spots. Okay? All right, let's try one more. Let's try 39. 39 is a little bit trickier. Desmond was pretty good at it in first hour, so let's see if anybody else can pick it up on 39. "39 takes a little bit more brain power. Kathleen?
X plus 5 over the square root of x minus 1 for g, and then f equals x.
It's cheap. Neither one of your functions can be just x. Okay? Because it says the directions say neither function may be the identity function f of x equals x, which is what you're doing. So neither function can be x.
G of X is X plus 5, and then F of X is X over the square root of X minus 1.
X over the square root of what?
X minus 1.
You guys like that? I don't like it either.
We're going to start to do this square.
Yeah, because if I do it, I do get the x plus 5 on the top. What do I end up with on the bottom though? Square root of x plus 5 minus 1, which is x plus 4. So it doesn't work.
Can you
It's a good thought though. That should get us thinking and help us figure out what we need to do. Bobby?
do V of X equals X minus 1 equals F of X equals X plus 5 over the square root of X.
What do you guys think about that?
Uh,
Same situation. The bottom works, but when I plug it in the top, I end up with x plus 4 instead of x plus 5. Okay? So, we're getting closer. I can feel our brain power. I can feel our brains working. Dick?
F of x is 1 over square root of x minus 6. And then g of x is x plus 5.
1 over,
Square root of x minus 6.
and the bottom is what?
X plus 5.
You're close.
Oh, I meant x over. Yeah. Yeah.
Alright, what do you guys think about that one? That one does work. Okay.
That's my brother.
If I put x plus 5 in the top, x plus 5 in the top gives me x plus 5. When I put it in the bottom, I get x plus 5 minus 6, and 5 minus 6 gives me the negative 1. So I do end up with that. There's one more I can do. Does anybody see the other one? Same thing?
I said same thing, but thank you.
Alright, so same thing, but different. What would that
Like, okay, instead of that, like,
be? What?
I have to look for it, but it's like the same concept.
It is the same concept. You're correct.
That give us the
X minus 1.
and, that's
Alright, so the top would be x plus 6, the bottom would be the square root of x. Does that one work as well?
yeah.
Yes, because in the top, x minus 1 plus 6 gives me the x plus 5, and the bottom I get the square root of x minus 1. Okay, so when you have multiple x's, it makes it a little bit trickier. So you got to think just a little bit more. Alright, very good. So that is performing function operations and finding compositions of function. Your assignment on page 61 is 2, 8, 10, 12, 16 to 28 even, and 30 to 38 even. And make sure on these first 4, I only want the domain of the last one, the f divided by g of x. The directions want you to give the domain of every one. I only want the domain of the last one, so you only have to give me the domain of the last one. Is that yours or